Hey everybody, Mr. Klein here, and I'm going to show you how to do the first problem on your assignment, which is about the chi-square test for independence. So what are we testing the independence of in this case? We are looking at whether there is independence between a person's sex, male or female, and the type of cancer that they have developed if they are a cancer patient. There's five major types of cancer. There's carcinomas, sarcomas, melanomas, lymphomas, and leukemias. All right, so we have gathered a sample of 400 cancer patients. We have recorded their sex and the type of cancer that they've developed, and we've recorded the observed data in this table here. What we're interested in is whether they are independent. So what we need to do is look at what we would expect the data to look like if they were independent. So the first thing that I do is I copy these data down here, and I delete the observed counts. As you'll recall, the idea is that we want to hold the row totals and the column totals constant, and then look at what we would expect to have here. And that the expected number of females that develop a carcinoma, if sex and type of cancer are actually independent, that expected number will be, there's 202 women times 175 carcinomas divided by the total number of carcinomas. So we would expect to get 88.4. We got 95, so we got more than the expected number. Okay, you can keep doing that for all of these. For instance, right here, I could say for males, there are 198 times 175. So row times column divided by 400. And you can keep going across for each one of these spaces. There is a shortcut. I'm going to show you the shortcut. It's kind of advanced, so I don't think all of us are going to be into it, but I'll show it to you. For this space right here, you can say, well, I want to hold the 400 constant, the thing in the denominator. I don't want that to ever change, so I'm going to $sign that. And then the first number, G8. G8 is over here. I would like for each one of these cells it either to be the 202 or the 198. So I want to hold the column constant. So I'm just going to $sign the G. And then for the B10 is right here. I would like it either to be the 175, the 16, the 50, the 73, or the 86. So I want the column to vary, but I want the row to always be 10. So I'm going to $sign the 10. Okay. Now, if I do that, I can just copy the formula, copy, paste, and paste, and there will be all of the expected counts. Okay, so when you're getting expected counts, you have your choice. You can either use that formula that I just showed you, or you can do them one at a time. It doesn't really matter. All right, now, from there, there's two ways you can go about running the test. One is this. Let me copy this again. So one thing that we could do is we could get the partial sums that go in each space. So for instance, if I wanted the partial sum here, I would say it is equal to observed minus expected squared divided by expected. And then I could just take that formula and I could paste it into each one of these spaces. Okay, so there's our expected counts. And then the next thing I would do is I would find the value of chi-square. And we do that by taking the sum of all of these expected counts. Sorry, not expected counts, the sum of the partial sums. Okay, so our sum is 5.1 or so. Our degrees of freedom in this case are going to be, we have 2 rows and 1, 2, 3, 4, 5 columns. So this would be equal to 2 minus 1 multiplied by 5 minus 1, which is going to give us 4 degrees of freedom. And therefore, our p-value, the same formula that we used last time, would be chi square distribution right, where this is our chi-square and this is our degrees of freedom. So we get 0.279, all right, pretty large p-value. Now, my guess is you're not going to do it that way because there's a much easier way that will immediately give you the p-value. Okay? And you don't have to calculate any of this at all. All you have to do is say chi square test. And then what you do, this is different than everything else we've been doing with Google Sheets. Instead, you go and you highlight the observed data. Notice that I didn't take any of the column, the margins, right? I didn't take the totals here or the totals here, just the observed data, comma, highlight the expected data. Oh, what went wrong there? Let's try it again. Right here, I want all of the expected data. And you'll notice we get the exact same p-value, and I was able to do it without calculating any of these partial sums. In fact, watch this. I'm going to delete the partial sums. I'm going to delete all of this, and I still have the p-value. So pretty cool. And you can use that method if you want. Okay. I think that's it.